This is Algebra 2, Lesson 76 on page 316. So there are two parts to this lesson. The first part, we're going to have three equations with three variables. So it's important to note, anytime you have an equation that has three variables in it, you cannot solve for the variables if you have fewer than three equations. So anytime you have a system of equations that has three variables, then you must have three equations to solve it, all right? So we're going to use substitution and elimination, all right? And when we substitute, we have to use all three equations. All right, so best way to do this is to work through the practice problems. All right, so look at 76.1 on page 316. We have x equals 2y. Always when you have a variable equals something, we're always going to use that for substitution when we have these system of three equations. Then we have x plus y plus z, x plus y plus z equals 9. And then we have x minus 3y minus 2z equals -8. So if I substitute 2y into both of these second and third equations, then I no longer have x. I only have two variables. I just have y and z. And then I can use substitution or elimination with those two. So that's what I'm going to do. For the value of x, I'm going to substitute in 2y. So we end up with 2y plus z is 9. 2y, see, for that in that place in both of these equations, I'm just substituting in 2y. Minus 3y minus 2z equals -8. All right, I'll simplify them. We'll label the equations 1, 2, and 3 so that you'll know which equation I'm simplifying, all right? So I'm going to simplify equation 2. Combining those y's, it's 3y plus z equals 9. Simplifying the third equation, it's -y minus 2z equals -8. All right, because I have a positive and a negative here, I also have a positive and a negative here. I think I'm going to take equation 2 and multiply it by 2, because 2 is smaller than 3, and eliminate the z. All right, so I will multiply every term in equation 2 by the value of 2. 2 times 3, 6y. That's plus 2z is 18. Now I can add equations 2 and 3. 6 minus 1, that's 5y. My z's eliminate, equals 10. Dividing both sides by 5, y, the value of y is 2. So now that I've solved for y, I wanted to solve for y because I wanted to be able to then go back and solve for x. So I'm always, when I'm going back in to solve for x and z, I'm always going back to the original equations. So the value of x is 2 times the value of y. X is 4. All right, and you can put this in a coordinate system, but now we have 3 coordinates. So this is a 3-dimensional graph, actually. All right, now I have x, I have y. I'm going to go and plug this in back to equation 2 and solve for z. So 4 plus 2 plus z is 9. That's 6. When I subtract 6 on both sides, the value of z is 3. So actually, I can write this as 4, 2, 3 in alphabetical order, X, Y, to Z. All right, next example is on the top of page 317. Again, we have 3 equations. I want one to be able to use to substitute into the other 2, then try to use elimination. All right, so these equations are 2x plus 2y minus z. 2x plus 2y minus z equals 12. They've labeled them A, B, C. It doesn't matter. 3x minus y plus 2z is 21. And the last one, x minus 3z is equal to 0. I'm going to let me number these. I'm going to take equation 3 and solve for x, then substitute into 1 and 2. So I'll add 3z on both sides, and the value of x is 3z. So I'm going to substitute this value into equations 1 and 2. And so for x, I'll put in 3z. So in equation 1, it's 2 times 3z plus 2y minus z is 12. In equation 2, it's 3 times, substituting in for x, 3z minus y plus 2z equals 21. I'm going to simplify the first equation. That's 6z. 6z minus 1z is 5z. I'm going to write the 2y first. Plus 5z is 12. In equation 2, that's 9z. 9z plus 2z is 11z. And y is just a negative. All right, I can take this second equation to eliminate y and just multiply every term by 2. So multiplying every term in equation 2 by 2, I have negative 2y plus 11z is 21. I rewrite equation 1 and I add them to eliminate the y. And we're left with 16z is equal, I didn't multiply the 21 by 2 or the 11. I'm just noticing that. This is not right. This should be 22. And this should be 42. 42. Right? It's a common mistake. Even I make. All right, so we're left with 27z equals 54. When you divide both sides by 27, the value of z is 2. All right, now that I have z, I'm going to go back and solve for x. So the value of x is equal to 3 times the value of z, which is 2. So x is 6. Now I'm going to go back to the original equation. I think I'm going to go back into equation 1 to solve for all of the variables. So in equation 1, we have 2 times the value of x, which is 6, plus 2 times the value of y, that's the unknown, minus the value of z, which is 2, is 12. All Right, that's 12 minus 2, which is 10. So I'm going to subtract 10 on both sides. And we're left with 2y equals 2. The value of y is 1. So writing them in order, notice we use the curvy parentheses when we have 3. That's what I do. X is 6, y is 1, z is 2. So it's 6, 1, 2.